Robotics, it's a competition that allows people to get in and start doing engineering things, seeing how industry works.
They're having a blast. There's 48 other teams here of kids just like them with the same passions and interests to go talk to go see what they did or learn from them.
I'm surprised on how nice everybody is. That's something that I really like to look for in people. And in a lot of places these days you can't find the nicest in some people. And here everybody can be your friend.
It's a playground of technology. It's a place where nerds get to compete as sports heroes. Everybody, a 25-member team, everybody's participating, no one's benched. It's awesome.
It's like running a small business, hiring new employees every year. And so you've got the business side of things, the sponsorship, fundraising, money management, purchasing. Then you got the technical side where you're managing programmers, you're bringing in mentors or recruiting mentors from industry to come in and work with the kids.
One of Dean Kamen's things when starting First Robotics was getting young people involved in building and engineering and stuff, because there are people who go to college for engineering and they've never held a tool in their life.
Most of them get inspired to do something more. A lot of my kids, in fact, one of them just told me now, another one of our sponsors hired one of our students right out of the program. So right now I've got 4 current members who are working for our sponsors in their industry, and then I've got a lot of student members who work for one of our sponsors in their summer camps. We have great community support. If you look at the banners that are on either side of us, they give us, the school gives us the space, the facilities, the time, and then local industry really picks up and sponsors the expense, the travel. A lot of this is community sponsored.
It's a lot easier to get money from a sponsor for a technical, where the kids are going to be engineers, where the kids are actually going to participate. Even if they don't get to drive the robot, that's such a small part. What part do they do in design? What part do they do in programming? What do they learn in the process? Everybody's gaining from this program.
One of the first parts is the drive system. It's 6-wheel drive, omni wheels in the corners, and pneumatic tires in the middle. This way we can turn on a point very quickly, and we get a lot of traction this way for climbing up the bridge. This chassis is made out of extruded aluminum, very strong, lightweight, and we can't break it. This houses our entire control system. All the electronics are in there, safe, protected, nothing can get to them, and it's easy to work on. For the ball feed, we used surgical tubing on plastic rollers that we machine on the lathe. It feeds the ball up from down there, and we can hold up to 5 balls, but we're only allowed 3. And once we get enough, we ramp these shooters up. It's 4 6-inch FRC wheels that spin about 4,000 RPM and can make a shot from anywhere on the field. We use Bainbots motors with just a little gearbox, and that gives us plenty of power, plenty of speed, and there's very little slowdown once the ball goes through. And then we use sensors here to monitor the speed of the rollers and tell how fast it's going. To lower the bridge, which is one of the biggest parts of this whole challenge, we made this arm. It features a window motor from a car geared to a very, very big sprocket from a little one, and can push the bridge down using this arm to allow us to drive over the bridge and score balancing points with either just us or 2 or 3 teams. So on the screen here, one of the first things we have is the camera. The camera features green LEDs to light up the target, which has reflective material around it. The camera then looks at the reflected light and sees the width and the height and which way it's tilted to give us the distance and then the angle that we're actually facing the target at. And uses this to calculate the speed to ramp up the shooting motors to feed the ball and make baskets.
It's a blast. It's, like I said, it's one of the most exciting things I've done as an educator.
The mentors, they come from shops and businesses that do this for a living. So they come in and show us how to use the tools, how to be accurate, how to get everything to work together and work well.
The hardest part for me being a mentor is to keep my hands in my pockets. I'm doing this because I love technology and engineering and design. I've heard so many times one kid talking to another saying, I made that or I designed that, and you can't beat that feeling. When they didn't know how to do something and they suddenly discovered it, they're pulling someone over, look what we can do, and the enthusiasm, it's amazing.
I was thinking about being a history professor at a major university or something, but this seems really interesting and I might have to change my plans.
So So they're getting tied to industry, they're getting great experience there, they're getting shoulder-to-shoulder experience with the technical expertise of our mentors, and they're getting inspired to do something they didn't think they could do. They're getting turned on to engineering and science and math, and it's applied.